Well, let's start. My name is Alexander Burluka, and I'm a software developer in Virtuoso company. I'm working inside the virtualization team, and I want to tell you about LibCT library, which I contributed as well. Yep. Let's start from a brief agenda of my talk. Well, first, I should talk a little bit of history of Linux container virtualization and tell you the main stages of it. Then I would talk about the building blocks which make containers work. Its namespaces and control groups. Then I will talk about LibCT itself, and we'll finish with the current state of project and its future plans. Well, first the history. Well, the history of Linux container virtualization takes its beginning from 2002 year when Project Virtuoso came on the scene. It was a product of SW Soft company, which were then Parallels, and now it's Virtuoso. Then in 2005 year, OpenVZ project appeared. It was a bunch of, it was a GNU GPL licensed Linux kernel, which allows to run a fully operation system containers. Then the project Linux Resolve appeared. It has the same functionality as OpenVZ, but it has a little troubles with the networking, which was solved looking ahead with a network namespace. Then in 2006 year, namespaces and control groups appeared in Linux kernel. And Linux containers as a technology starts in 2008. In 2010 appeared a Docker. It's made a revolution. We're all talking a whole day about Docker. I won't tell you anything new about it, but a little bit of history. Well, systemd and spawn was the first utility which allows to run some kind of application containers. Initially, it was made for a debugging or testing purpose. Then appeared a Docker. Docker uses LXC as its engine. Then after some time, it's forked a libcontainer, and it's available on GitHub. Rocket project uses systemd and spawn to run the containers. The main merit of its project is open container standard. Well, I think the history is not some interesting, so we go to namespaces. Well, I will list namespaces as they appeared in Linux kernel. The first and the eldest namespaces is mount namespace. It allows you to get a fully mount system, file hierarchy in your program. It means that you won't be able to hurt a host file system. Well, the next is network namespace. It allows you to create some network devices, traffic shaping, and so on. You may create some kind of a network topology with the help of network namespaces. Then PID namespaces. It prevents a process to view the process in other PID namespaces. For example, you cannot kill a process in other namespace. Well, inter-process communications, so it's message queues, some kind of semaphores, and so on. UTC namespaces, it's host name and is domain name, as you can see. And the one is most latest and one of the most important user namespaces is user namespace. It's very important for application containers. Why I should talk on that slide? That feature is quite important. I talk about user namespace. It allows you to run your container without having root access to system. It's quite important for the security thoughts. I think you cannot talk about application containers without user namespace. The next main feature is that namespaces can be created once and used many times. You can reuse it. It's quite important because creating of namespaces is a little cost in some cases. For example, if you use mount namespace, it needs you to rebuild a file system tree every time that you use it. But for example, a UTC namespace used only a couple of syscalls. Fast entering, you can reuse it fast. You create namespace once and you reuse it whatever you want. And so I think that ability of isolating tasks is quite obvious from that context. Well, let's move on. Typical usage scenarios of mount namespaces. Well, I suppose that the main users of namespaces and containers at all is the hosting providers. Well, the mount namespaces, for example, let them isolate their users on their host system. Some mail factor cannot hurt your host system if you isolate it with namespaces. Well, it gives your hosting product is multi-tenancy. Well, network namespaces, as you can see, is network topology, as I said it before. You may build it complex, and if I remember it right, Michael before me done some of this stuff. Well, the PID namespaces I described it earlier. You cannot kill other processes. Well, do anyone has any questions on namespaces? Well, let's go to the control groups. Control groups is a limitation of resource. If namespaces gives you an isolated instance of resource, this control groups limits that instance. Well, it's quite obvious. Is CPU set, it limits CPU scheduler, amount of CPUs on a multi-process system. Memory control groups, which is limits memory of container. Input-output devices of a host system. Networking, you may give a class identifier to network shape, network traffic, sorry. Freezer, which was in a previous talks, and so on. Well, I think that's enough with the C groups. I think all of you know about that. Well, the LibCT library itself. Well, what is this and what for it need? Well, the main, the start of LibCT library was on a Linux call, where Pavel Yemelyanov, he sits here, and James Bottomley talks with the Docker and the Linux container community, which we want Docker to use our OpenVZ backend, not only the Linux containers, but OpenVZ as well. As a result, Docker made a lib container and put it on a GitHub, and we start to develop that LibCT library. The LibCT library is kind of a high-level, high-level library which allows you to create containers on other systems. Currently, it implements only Linux containers and OpenVZ, but there are no problems to implement FreeBSD or Solaris zones. We would be glad if some of one do that for us. We only interested in Linux. Well, you may run containerized applications. We use that primitives as namespaces and C groups because of Linux container virtualization is much production ready than other systems like FreeBSD and Solaris zones. So we use namespaces and C groups to configure container. Because of you may use the user namespaces, you may create unprivileged containers. It's written in C, C99, and it's quite portable. You may compile it on every system that have a GCC on it. Well, it's cross-platform. Well, the next. The reasons. The main reasons why its library is neat, we suppose that it's too hard. It's too hard to use a creation of containers in your applications. Well, in Linux, it's a bunch of syscalls. It's quite hard to understand. When I implement OpenVZ backend, I spent about a month to get on some strange things, and it was quite hard. So we reduce the complexity of that, and we think that LibCT is quite simple to use. Well, I talked earlier about the support of all kinds of containers. We can support only Linux containers and OpenVZ currently. Well, low-level IP changes, for example, C groups. C groups currently can be set via file system and via systemd interface. I suppose you know about it. Well, I would like to talk about the relation of libcontainer and libct. They are mostly twins. Earlier was an idea to merge that libraries. But when a Docker con a Docker community on Docker con said that they use now runc utility, there is no need to merge that library now itself. Well, I suppose that most of the difference is because of languages in which they was written. libcontainer is written in GoLank, and I think anyone don't know about GoLank. Well, it's quite simple. It has a big community and easy to write and easy to execute. libct is written in C. It's a little bit hardcore in some places, but we think that it's an advantage of it, as we get a little bit faster execution of a libct. libcontainer and libct both support backends, as I said it before. And, of course, develop your program in C is quite harder than use any language that is quite young, such as Go and Python. Yep, we work faster, but we are a little bit harder to contribute. And GoLank has a little constraint which I don't understand fully. They did not have a fork syscall. They had only fork and exec. Why it was done, I don't know. So to integrate with Docker nowadays, you need to write a command line utility, such as runc. Well, anyone has a questions about it? Nope? Well, let's go for example. Example, well, you see that it's quite readable. We create a session, a local session, then we configure containers, you can see in third line, with name test. Then you specify 3 namespaces, it's speed, UTC, user namespace, and file system namespace. Then you configure user namespace and temporary file system, so your test container won't be able to get to the host system /tmp. Then you configure a process which you want to execute in there. Then you start it and wait for its end. And the last lines are only a cleanup. It's absolutely simple, I think. You don't need to call in a bunch of syscalls, and I think it's quite obvious. You start a session, you create a container or load existing, you configure it, specify a process, and start it. All is easy. Well, I would like to tell a little about primitives which are used in that library. The first is session handler. Session handler allows you to save a host parameters, and you create within that handler a container, load an existing one. Next handler is container handler. It allows you to configure it, configure namespaces and C groups, so on. And it allows you to create the process descriptors. You fill that process descriptor and start the process. Well, anyone got a question about the code? Well, good. Well, the next one is my future plans. Currently, we had a lack of developers in that library, so we did not have much examples of code. Actually, LibCT library needs to be developed actively. The first and the main idea, for example, you can use Apache with it and start every model of Apache in a outstanding container. We want to add notification in that library, so if one will set up a C group outside the LibCT, then you will get a notification about it in your program. Taskless containers is a kind of economy. You create container once, and then you reuse it for some other processes. So you open a container, put a process. It's finished, container remains, then you get another process, put in, and continues. So it's kind of efficiency. Well, integration with Creo library, which would be nice to use. Well, actually, I think that's all. Well, got questions? Well, thank you.